So today we're going to start a new topic. Woohoo! I like new topics. I'm not telling you what it is just yet, even though the astute among you may be able to guess, but you can leave space for a heading. The date is the 29th of April. We're going to begin by just considering the big, and I really mean big idea of proof, all kinds of proof. What is proof? What does it mean to prove something? And I mean that very broadly, not just in like the mathematics classroom. What would it mean to prove something? What's proving about? Evidence? Yeah, providing evidence. Evidence for what? Evidence for an argument? You try to convince someone that something is true, right? That's what a proof is about. Prove beyond a shadow of a doubt that there's no way you can reasonably doubt whether something's true or not. Okay? Now, there's lots of different kinds of proof, depending on what you're trying to convince someone is true, right? And because the different things work different ways, we have different proofs for each of them. So, example, we live in the scientific age, right? So, scientific proof, what is it? What's it set out to prove, and how does it work? Not a rhetorical question. What does scientific proof, what kind of truth are you trying to convince someone of if you use a scientific proof? What kind of truth?
Theory.
Is scientific proof, for instance, is it interested in, like relationships between human beings or things that have happened in the past? Not really, right? What's science about? Science is about, well, do we have a definition from like, I don't know, from year 2 or 3 when you first start learning about science and how experiments work? It's about the natural world, isn't it? It's about natural phenomena that happen over and over again, and you can observe them and you can see the patterns, right? So therefore, if that's what scientific proof is about, how does it actually function? How do you prove something scientifically? You have to make a situation, right? You have to be able to control it, and you have to be able to do it how many times? Many, many times. Over and over again. So, scientific proof, good morning, it's about repeated experiments and observations, and then you make a hypothesis and so on. Okay, well actually you're meant to make the hypothesis first, aren't you? But anyway. There you go, there's the idea. Now, I alluded before to the fact that not all kinds of proof are like this, right? For instance, the exact opposite of this, right, is historical proof. Historical proof. This is about things that have happened and cannot be repeated by their nature. That's what makes it history, right? So, being that you can't prove historical things scientifically, how do you prove things historically? How can you know, like, you weren't there 100 years ago, 1,000 years ago, all this, but we speak with confidence about, yes, this happened, this is true, this is history. How do we do it? Fossils, evidence. If you think of dinosaurs. Well, but what do you do with these things? You just put them in a heap and then say, well, look, there you go, there's stuff. How do you put that all together in order to constitute proof? When it comes to fossils or evidence, maybe that's like eyewitness accounts or records or something like that, what you're looking for is the best explanation that ties all of these things, whatever we have recorded, ties them together in a causal way. Okay, you're looking for relationships, right? You're like, World War I, it happened. Why did it happen? What's the best explanation for all of the things that we observe, for Franz Ferdinand and his assassination and all the people who allied themselves, blah, 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 blah. What explanation can put all of this together, right? And when you come up with a good one, you say, well, this is what happened. This is how you can historically prove something. Right? Now, scientific proof, historical proof. This is not a science or a history classroom, though, is it? Right? So, even though there's more kinds, the last one I'm interested in talking about, of course, is mathematical proof. Now, so I hear someone say English proof. Now, mathematical proof, again, just like these, they're all different. There's different methods associated with different truths that are being handled and argued about, right? So, if this works by repetition, this works by putting together evidence in a causal way, how does a mathematical proof work? Think about it. You've been proving things for years. You know a lot about mathematical proofs. How do you do it? What kinds of pieces, experiments are the pieces here? Evidence are the pieces here. What are the pieces that make a mathematical proof? Algebra, statements, there's propositions, right? Propositions, that's important. Propositions. I can spell. It's too early. Sorry, guys. Propositions, you put them together rather than with, I think this caused that, right? We put them together with logic, right? And then you form an argument, just like you would with any of these, okay? But, right, mathematical proof, even though I'm kind of presenting it as like equal, one among equals, it's actually very, very different from the rest, okay? Because mathematical proof is the only kind of proof, not just this list, of any kind of proof you can think of, right? Which is irrefutable. Mathematical proof is the only kind of proof that is irrefutable. What's that mean? What does it mean to refute something? In a debate, there's refuting, right? Which is to say, no, they're wrong, idiots. That first speaker, what a joke, right? That's refuting things, right? But mathematical proofs, if you prove something mathematically, it can never, ever, without a shadow of doubt, if you really did prove it, it can't be refuted because there have been false proofs. There are many false proofs out there for different things, but if they're real proofs, if they're mathematical, you can't refute them. Whereas you can scientifically prove something, and it can be according to the scientific method or historically. You can have all of the best pieces of evidence and arguments and all that kind of thing. But, well, science and history get overturned all the time. How? You make a new discovery. You find new evidence. You're like, this blows everything out of the water, right? We never did land on the moon. Oh no, or whatever kind of conspiracy theory you like, right? But it doesn't matter how much new mathematical stuff you discover. If you discover something that's mathematically true and you prove it, it's always true. Example, you can take any whole number, and you can write it as the sum of 4 squares. Did you know that? Any whole number you like. 4 square integers, okay? Think of one. Give me a number. Should stop asking for numbers. Okay, I'll make up my own one. Come on, let's divide it up. We can divide it up into 4 squares, or less, but you just make it 0 squared, which is how you do it. What would you take it? What's the biggest square you can fit in there? Come on. 12, surely. Okay, 144, right? 144. So that'd be 3, wouldn't it? What's the biggest square you can fit in that? It's 1, isn't it? You do it 3 times. So you go 3 minus 1 squared is 2. 2 minus 1 squared is 1. 1 minus 1 squared, you get to 0. So 147 is 1 squared plus 1 squared plus 1 squared plus 12 squared. Okay, that was a bit boring. Give me a different number. How about 210? What's the biggest square you can fit in there? 14. What's that? 196? So that would leave you with 14, wouldn't it? Is that right? Yeah? What's the biggest square you can fit in that? 3. That's 9. That should leave you with 5. What can you fit in that? 2. That's 1. Oh. Whoops. Wrong one. 210 is 1 squared plus 2 squared plus 3 squared plus 14 squared. We could keep playing this game for a while if you liked. It's been proven. This is called Lagrange's 4 square theorem for obvious reasons. Okay? It's always going to be true. There's nothing new that can ever be discovered that will disprove this statement. Okay? That's interesting. It's pretty freaking awesome, right? Mathematical proof is unique in that way. Okay?